Record. Okay.
All right. Hello, I'm Jeff Krehmer, the author of Infinite Resources, and I'm here with Roger Carlson, the author of the Saving the World Before Breakfast series. And together we're saving the world before breakfast with infinite resources.
Yeah.
And today we are going to be talking about the Arctic Energy and Resource Symposium that I attended last week, where I gave a presentation, and I will re-present that here for the group. And I've invited Roger to basically interrupt the presentation if he has any questions or comments on anything that I'm presenting, and then we'll have a discussion about it afterwards.
Mhm.
So with that, I will share. So I did this in two parts. Oh, sorry, let's stop sharing. I chose the wrong one. I did this in two parts, and the first one is just a short teaser, and the second
Mhm.
one is the main presentation. So,
Okay. And confirmation that it came up with your intro page, introducing ocean atmosphere temperature, blah, blah, blah.
right, exactly. So here's the presentation. So challenges in Canada's Arctic. Well, of course, the climate affects everything up there. And if you're talking about materials, if you're talking about, life, permafrost is both a blessing and a curse, and melting permafrost is a problem. Of course, there's frozen waterways, and all of it's changing with climate change. And then the territory is huge, and I'll show a little bit about the territory later on in terms of the overall size. But because it's so huge and there's such a small population, it affects mobility, and there's not a lot of infrastructure for transportation. There's also limited resources. The government funding is limited. The size of the population is limited. And then the cultural clashes. So I didn't want to get into much of that, but there's changing traditions and, of course, a history of clashes between Indigenous people and the government. And we're currently on a path of reconciliation, which is good for everyone, I think.
Mhm.
And then the sovereignty concerns. So Russia has claimed everything up to the North Pole. China considers themselves to be a near Arctic country. And now the United States is, if you listen to people like Steve Bannon, they're actively promoting the idea of invading Canada's Arctic. So some things that Canada is known for, well, obviously the extreme cold. And if you're a fan of the arrogant worms, rocks and trees and trees and rocks and rocks and trees and trees and rocks and water. But in the high Arctic, there are no trees, and everywhere has rocks. So that just leaves extreme cold, and that's extremely cold air and cold water. So what can we do with that? Well, here are my solutions to those problems. Turn the cold water to our advantage and the cold air to produce energy. So if the problem is global warming, let's maximize global cooling. The vast territory is an asset with tremendous natural resources. Turn the limited resources into infinite resources, and that's, of course, the name of my book. And working together, we can reach mutually agreed upon and mutually beneficial goals to reduce cultural tensions. And by developing the Arctic, increasing the population, and increasing access to the resources, that's the best way that I think we can promote
Mhm.
Canadian sovereignty in the Arctic. So in part two, I'll teach you how to transform cold water and cold air into abundant, clean, renewable energy, and how to turn that energy into good skilled jobs and economic prosperity for communities and territorial governments, improved infrastructure and transportation systems, sustainable and ecologically sound resource development, increased global trade, intelligence, information, and commerce, sustainable and healthy food for domestic consumption and export, prosperity for all, and strengthening sovereignty. So we'll see you at the next session. And there, of course, is my contact information. So I'm going to stop sharing that. And then I'll go into the next presentation. So I have to escape out of that too. All right. So I can close that one down. And do you have any comments on that, first of all?
The only that might be to make it clear for the audience, it'd be was it cold water and colder air for a temperature difference,
Exactly.
or do you want it to be a surprise?
Well, I said cold water and cold air, but cold is doesn't quantify the temperature particularly. So
Mhm.
yeah, you need a temperature difference. But I will go into that in this coming
Mhm.
presentation. So if that was the only thing that came up in your mind, then that's good, I think.
Although the other thing that comes with it is, come to think about it, you it's a low southern summer sun that you get. I guess you could save some of that heat for later, and so in that case, you would be using you get yeah some yeah alternative heat source. And
Well, yeah, and the area that I'm talking about is really the high Arctic. So I'll go through this. I mean, it will
mm,
work as long as you have a good enough temperature difference between the water, the freezing point of
mm,
water, whether it be salt water or fresh water,
mm,
and the air temperature, you can produce some energy from that. So I'll just jump
mm.
right into it. So I like to start this out by saying, what do you see in this image? And since you're the only participant here, what is it that strikes you in this image?
You can see the frozen wilderness, and having read your book, I would say, but underneath that ice is water that is still liquid and is warmer than that frozen surface.
So you've got, yeah, you've given away the thing. So, I mean, a lot of people who think of the Arctic, they think it's just a frozen wasteland. It's an inhospitable location. Of course, there's remoteness. You don't see a lot of people there, a lot of ice, a lot of snow. And for half the year, it's dark most of the time. And for some people, some brave and hardy souls, they call that area home. So what you don't see are the plants and animals living under the ice. You don't see the liquid water, and you don't see the temperature of the air or the space. So
Mm,
just a bit of a background there. The background temperature of space is about 3 degrees above absolute zero. So you can reject a lot of heat to space. And I just wanted to point out this is an AI generated image, and the reason I point that out is because I'll be mentioning some applications of AI in the Arctic in a moment.
mm,
So, the presentation outline. So, I'm going to talk about how we can replace fossil fuels as our primary energy source. And by the end of this presentation, I'll teach you how to turn cold seawater and cold air into energy, food, drinking water, jobs, artificial intelligence, and money. I'll also ask for your involvement in 3 ways, and that goes for the audience who might be watching this recording as well. The details are available in Infinite Resources, and that is currently pretty much exclusively available on Amazon if you want to check that out. So, a lot of people ask me, how can you have infinite resources on a finite planet? And I'd like to just point out that definition number 2 for infinite is immeasurably or inconceivably great or extensive or inexhaustible. And resources, several of these definitions work, but a natural source of wealth or revenue, often used in plural, a natural feature or phenomenon that enhances the quality of human life. So
mm,
an example of an infinite resource is the water cycle. And, for literally billions of years, the oceans have been evaporating, basically creating fresh water
mm,
and allowing the liquid water to flow on land and provide, life-sustaining resource there.
mm,
Okay, so I like these quotes. Rewiring the energy system is a multi-trillion dollar business opportunity that is good for the climate, good for humanity, and good for sustainable economic growth. And then I've got 3 quotes from my mentor, Peter Diamandis. The world's biggest problems are the world's biggest business opportunities. The best way to become a billionaire is to help a billion people.
Mhm.
And imagine a world of 9 billion people with clean water, nutritious food, affordable housing, personalized education, top tier medical care, and non polluting ubiquitous energy. Building this better world is humanity's grandest challenge. So, along those lines, the United Nations has come up with 17 sustainable development goals. And the ones that I touch on directly are um, replacing fossil fuels, which falls under climate action. So that's sustainable goal number 13. By producing abundant desalinated water, we're helping sustainable goal 6, which is covered by our faces in my screen, anyways.
Mhm.
And
Yeah, I'm seeing
then
it at this end, and I've seen it. Some other people were presenting with that chart of
right,
goals as well, with the same pictures, I believe.
excellent. Okay, and
Mhm.
then easy access to affordable energy, so reduces poverty, which eliminates hunger and makes health better, and so on and so on. So in my book, I make the case that every one of these sustainable development goals can be advanced by adopting the technologies I write
Mhm.
about. So right now, there are 2.2 billion people who don't have access to clean, reliable drinking water on a daily basis. And if you think about it, that's 1 in every 4 people, more than 1 in every 4 people. And that's something that we definitely need to do to improve to help with humanity's lot. So energy is all around us. This is a slide that I actually gave to my son's grade 5 class when they were learning about energy. So you got energy in all sorts of different forms. That's a picture of Revelstoke Dam in British Columbia. That's Air Canada flight flying over New York City. And of course, we got renewables. And what I'm going to be talking about is how just having a difference in potential is how we can extract energy. And specifically, if you have a hot temperature and a cold temperature reservoir, you can transfer heat between the two and in the process produce work. So, what does that look like? Well, let's talk about global energy, the global energy situation. And this was from a couple of years ago, in 2022. And you can see we've got traditional biomass, coal, oil, natural gas, hydro, nuclear, wind, solar, and other renewables. So if the problem is climate change and that's related to burning fossil fuels, which clearly we get the majority of our energy from today, then the competition to what I'm proposing is business as usual, just continue burning those fossil fuels. But in 2022, a total of 178,889 terawatt hours of energy were produced or consumed, I guess. So just talking about the fossil fuel aspect of it. So for this, the information I have here was an average based on the years 1999 to 2018 in billions of US dollars. So I wasn't able to find the specific year totals for these, but anyway, you can see in a single year, we're looking at over $3.6 trillion spent on fossil fuels. So Canada's GDP, and this presentation, of course, was made to a bunch of Canadians. So Canada's GDP in 2022 was 2.16 billion US, or sorry, 2 trillion 160 billion. Yeah, US.
Mhm.
All right, so some basic high school chemistry here. So you might recall that if you have a block of ice and you melt it, that means that you have to add heat to that ice to melt it. And the amount of heat that you're adding to it is 334 kilojoules per kilogram. And when you go the opposite direction, when you have liquid water and you freeze it, that liquid water gives off 334 kilojoules per kilogram, and that's called the latent heat of fusion. So just some basic ideas here. A kilogram of water is a liter of water, and 1,000 kilograms is a cubic meter of water. In its liquid form, when it expands as ice, it's a slightly larger cube, but we'll get into that later. So if we look at Canada's Arctic or not Canada's, the whole Arctic Ocean in 2024, you got March of 2024, the maximum extent of the sea ice. So the dark blue line around here is the normal extent of the sea ice over the last 20-ish, 30-ish years. And you can see that it's all the way from James Bay across the Arctic Ocean to the coast of Russia is frozen, including the coast of Labrador and Greenland and out through the Bering Strait. And then the minimum sea ice extent, again, the dark blue is the average melt, but you can see for September 2024, it was significantly below the average. Anyway, the difference in extent between the maximum and the minimum is 10,730,000 square kilometers. Now, I'm not going to bore you with all the math, but if you do the analysis on how much energy that represents just naturally freezing and thawing, that's 5.6 times all the energy humanity uses in a year. So imagine if we could harness that energy and use it to replace fossil fuels. And the good news is that we can. So Canada's Northern Territories compared to Central Alberta. So you'll get to see where I live now. This is, of course, Canada's Arctic territories, and they're made up of Nunavut, which is this region here, Northwest Territories, which is this region here, and then Yukon Territory, which is here, for a total population of 130,620 people, according to Wikipedia from a couple of years ago. And the area is 3,826,000 square kilometers. So let's put that in perspective. This is where I live in the town of Black Falls. We're just north of Red Deer, and the next town north of us is called Lacombe. And this is the population density of those regions, again, from a couple of years ago. So Red Deer has just over 100,000 people. Lacombe has nearly 15,000 people, and Black Falls has about 12,000 people. So a combined total of 132,000 people living in an area. And this is about 50 kilometers north to south and 10 kilometers east to west. So that's 500 square kilometers. So, we're very densely packed compared to the Arctic territories. So Canada's Arctic is 40% of our land mass and less than 1% of our population. So this is the innovation that I'm talking about. And I have to say, this is not an innovation that I came up with. This is a technology that's been discussed, well, for over 100 years, quite frankly. But I first read about it in a book called Engineer's Dreams by Willy Ley. And here's the basic concept. So if you have cold air outside, anywhere from minus 20 degrees Celsius to minus 80 degrees Celsius, you will, of course, if you have a working fluid contained inside of a container like a propane cylinder, I'll use propane for this example, then that liquid propane is going to have a certain vapor pressure. And if it's very cold outside, the colder it is, the lower the vapor pressure will be. So what we can do is take that liquid, pump it below the sea ice where it will absorb heat from the ocean. And you go through a preheater. Basically, if this temperature is, say, minus 42, then that liquid will warm it up to close to the seawater temperature, and then you run it through a second heat exchanger to get it to the maximum temperature. And a lot of people don't realize this, but if you go down deep in the ocean, anywhere around the world, the temperature is between 3 and 4 degrees Celsius. And so we can raise that temperature above the freezing point. And when we do that, think of that propane cylinder. So if you got your backyard barbecue, as you warm it up to the freezing point, now it's going to have a higher pressure in terms of gas or the vapor pressure. And then I have here heat from other sources, and I'll talk about that in a later, but just note that you can add extra heat to the propane to give it even more energy and increase the vapor pressure. And then once you've got that pressurized gas or vapor, you can run that through a heat engine, which can either be a turbine or a piston engine. And then run it through a generator. Now, I should point out, when I was doing this presentation, there was a lady before me who was presenting from, I believe it was General Electric, and she was talking about a self-contained nuclear reactor, which I know is near and dear to your heart. And anyway, I said that, the heat exhaust from that nuclear reactor would be a great additional heat source to increase the efficiency of this overall process. So going back to that previous image, so the high temperature in this case is the cold water in the Arctic Ocean or the Antarctic Ocean, depending on where you're going to be. We can extract work through that by transferring that heat to the cold temperature here. And another example of what that looks like, if you think in terms of a steam engine, the ocean represents the firebox. Instead of burning chemical fuel, we're just changing the liquid water into solid water and absorbing the heat from that. And then we are creating a pressurized working fluid. So in the steam engine, that working fluid is water that turns into steam. And then they run the steam through the piston here, and that produces power for the wheels in this case. And then they just release the steam out the smoke box to keep the flames going. But in our case, we will recapture that vapor and condense it and continue it on a continuous cycle. The intention is you don't want to lose your working fluid. You just want to keep recycling it. So scalability, it should be noted that the only limitations on how much energy you have are the temperature difference between the water and the atmosphere, and the size of the equipment that you use to transfer the heat and extract the energy. So I should point out here, removing heat from liquid seawater produces potable ice and cold brine, just like in nature. So this mimics that process where we're talking about the ocean freezing over. What happens there is you end up getting drinkable water when it melts in the form of ice, and the denser brine falls to the ocean floor. And that dense brine falling to the ocean floor is what drives the ocean currents, like the Atlantic meridional overturning circulation, which gives Europe a favorable climate. So as a case study, consider Alert, which is at the northern tip of Ellesmere Island in Nunavut. So you can see that for basically 6 months of the year, the average temperature is at or below minus 27 degrees Celsius. And then, and you can see that there's basically no light up there for 5 months completely. And then for the other half of the year, you have pretty much continuous sunlight. And what can we do with all that sun energy? Well, you could do something like this. And I know that they just are shutting down the Crescent Dunes solar plant, but and that's because the cost of electricity was not competitive with solar panels. Quite frankly, we could use solar panels in the Arctic too, but if you want to use this same system, it's better to use concentrated solar, and then you can get a water vapor cycle and then get a secondary propane vapor cycle to generate power with. And instead of condensing your steam at around 100 degrees Celsius in atmospheric conditions, you can condense your steam by heating up propane at around that temperature. But then you can take that propane and run an entirely different cycle and condense it around the freezing point of seawater, which is minus 1.8 degrees Celsius. So what can we do with that energy? Well, there's an entire economy. I'm going to shut the door here. I'm doing a presentation here. Trouble with presenting with family in the house. So a lot of countries, particularly in Europe, Germany in particular, is very keen on moving away from fossil fuels to renewable green hydrogen. And this is one way we can produce it. So what can we do with hydrogen? Well, Canadian Pacific, Kansas City rail line here, they actually have a locomotive that is currently operating using hydrogen. Hydrogen could be used as a lifting gas for blimps. And when I was talking about improving infrastructure in the Arctic, I think setting up a transportation system using lighter than aircraft makes a lot of sense, because that way we don't have to necessarily build roads to every community. We can still supply the communities, and you can think of these floating airships as being floating fuel tanks to generate electricity with. Beyond hydrogen being used as a fuel or as a chemical feedstock, we can combine it with nitrogen and produce ammonia. Ammonia is a much easier chemical to work with than hydrogen because you can contain it much more easily. You don't need to compress it to the same extent that hydrogen does, and it liquefies well above absolute zero. So unlike hydrogen, which if you want to turn it into a liquid, you have to get it down to just a few degrees above absolute zero. And hydrogen has, or ammonia has other uses, which include being a fertilizer. It can be used directly as an energy source. If you, with minor modifications to a diesel engine, you can run ammonia in a diesel engine. And a lot of people don't know this, but ammonia was the main fuel that was used in the fastest recorded aircraft flight of the X-15. And it's also a precursor for explosives and can be used for other chemicals as well. So if you're looking for a hydrogen economy to replace the fossil fuels, this is a possible source to get the green energy from. And just to give you some ideas of the market, the current market is $204 billion. That's expected to grow to $603 billion by 2034. And I think if we could supply more of it, we'd even be able to get a larger market than that. And ammonia's market is also expected to grow. Currently, it's in around $214 billion. So can the ocean freeze? Well, I've already shown you that it can freeze, but this is from NOAA. And they say here, when seawater freezes, however, the ice contains very little salt because only the water part freezes. It can be melted down and used as drinking water. So what do we do with all that ice that we're going to be producing through this process? Well, this is taken from my book. And essentially, if you imagine, the way I came up with this is, this is 1 ton of ice, and you can see the water expands slightly. So it's 1 meter by 1 meter by 1.1 meters. But you can get 16 of these together. That's about a tractor trailer load of ice. And if you have 1,000 of those truckloads, that's what I call a tanker. If you put together 25 of those tankers, that would be what I call a berg. And then you assemble those bergs and you end up having this super berg configuration. And so this is approximately 5 million tons of ice, or water, if you will. And it's nearly 1 kilometer long and nearly 1/4 of a kilometer wide. And you can imagine this thing going through the Strait of Gibraltar, and little chunks of it being directed, self-directed with satellite navigation to different countries as it goes through the Mediterranean. And how do you pay for this? Well, I think one of the markets I'd really like to displace with renewable water from the ocean, desalinated water from the ocean, would be the bottled water industry. So you may receive emails from time to time talking about how such and such company is taking water out of an aquifer, and it's affecting the local animals and creatures. Speaking about creatures, I got one right here who wants to make an appearance. Hi, Luna. Anyway, this has the advantage of we're not taking water away from anyone. There's no other stakeholders who really have a claim to water from the ocean. Everybody has a claim, has the same claim. And if we can convert that salt water, desalinate it, and get it to people, that's a bonus. And along those lines, I'm in the process of applying for the X Prize Water Scarcity Challenge. And I won't talk too much about that, but I have to make sure I get that in before the deadline, which is March 31st of this year. So what else can we do with the energy that we have up there? Well, we could produce a greenhouse. And when I say greenhouse, this is a shipping container. So clearly it doesn't have glass walls or anything like that. But in the Arctic, if it's dark for 6 months of the year, it doesn't matter if your walls are transparent or not. In the summer, it would, of course. But if you can control the now let's bring up the notes here. If you can control the temperature and you can essentially extract heat from the ocean, as we're talking here, with a heat pump, you can produce light with the electricity. You can fertilize it to some extent with the ammonia, and you end up having the ability to grow pretty much any crop that you want on the polar ice cap. So I think that is a something to consider, and because people in the Arctic, I think, are paying at least 4 to 8 times what the rest of us pay for groceries, because everything has to be flown in, particularly in the wintertime. So bonus number 2, well, the polar oceans are the most bioactive oceans in the world, but in the wintertime in the Arctic, when there's no sunlight, that bioactivity drops off because the sun, of course, drives the growth of the algae and the different plants that grow in the ocean, and they are the food source for all the other creatures. But I also want to point out here that the most expensive part of this deep ocean fishing operation is the platform. Well, if we already have a platform that is there to produce energy, it's a very small add-on to add the stuff that's necessary for fish farming. The food chain is completely natural because, of course, you're taking it from the Arctic. And the only thing that's missing is the light. And we can produce that with electricity. So imagine, Canada recently made it illegal to operate fish farms in the coastal regions around the country because they had a lot of problems with invasive species, and the fish make the local environment toxic, and there's diseases and stuff. So they basically said you can't pen in these fish and have a high concentration of them to grow, which I'm not necessarily a fan of that decision, but I can understand the rationale. But in this system, imagine if you're in the middle of the Arctic winter and you shine lights into the ice, and all of a sudden you get mats of algae growing on the bottom of the ice. And then you get the copepods and the krill, and they start feeding off of that. You think that's going to attract the larger fish, the salmon and the Arctic char? I expect it would. And in that case, you don't even need to have nets in the ocean, because the creatures will stick around where the food is. And if you're only lighting up one section, you just basically need a fishing license and go in and fish them out when you want to catch them. So, I could see a really good market in sushi restaurants, high-end sushi, fresh fish direct from the Arctic, shipped out by airships. All right, so the aquaculture market is $370 billion and growing. So let's talk about the bonus number 3. So if you've got that energy, what else can you do with it? Well, you can run data warehouses. You can do artificial intelligence, which currently is a market of about $757 billion, expected to grow to over 3.6 trillion by 2034. Currently, the market cap, and I realize market cap is not how much you're getting for generating it and stuff, but anyways, the market capitalization for all of cryptocurrencies is, well, let's see, this is thousands, hundreds of thousands, millions, billions, so $2.74 trillion, of which the majority is Bitcoin. And then, so you can make money, of course, mining Bitcoin as well. And one thing to point out is recently there was a fiber optic cable network that was built through the Arctic, and that connects Japan to Europe through the Northwest Passage. So a lot of these Arctic communities are connected to the internet directly. But even if you're not able to tap into that fiber optic network, you can use satellite communications like Starlink to upload and download information. And if you think about it, when you do a query on a search engine, or when you do calculations for cryptocurrency, or when you're doing compute for artificial intelligence, all of that compute happens in the server, and then you're just transferring a small amount of data back to the user. And all of that can be done with satellite technology. And then, of course, there's data warehousing and cloud computing and so forth, which is, again, a multi-billion-dollar industry. The reason I have the values for all of these different potential industries is because we're talking about improving the economic conditions in the Arctic and developing different technologies and potential industries. So along those lines, continuing with the computer case, if we look down here on the bottom left, you can see that servers consume about 43% of the power that runs a network like that. 3% goes to operating the network, 11% to the storage drives. And this system shows what it would be like if you're setting up a computer network in Palo Alto, and 43% of your energy. So basically, as much energy as you're spending operating the servers, you're using to cool the servers. Well, in the Arctic, of course, the cooling is free, and you don't have to have any additional power used to cool it. But the bonus is, you remember when I was talking about alternate sources of energy to power the OTEC system? Well, operating computers and using the waste heat can help you to make that whole energy system more efficient. And I was playing around with Grok just yesterday and doing some calculations. And if the temperature outside is minus 45 degrees and you're running a 1 megawatt computer farm, the basic calculation was that you could recover about 650,000 kilowatts from that 1 million kilowatts back. So it almost becomes a self-sustaining process. And then if you look down here, you can see that this is from a few years ago, but this is the amount of compute or the electricity that's being used to mine Bitcoin. So that's going from 2021. So approximately the same amount of energy as the entire nation of Sweden uses. And I've heard that it'll be as much as the entire nation of Italy in a couple of years. All right. Oh, and the other thing I wanted to mention is, even without these huge server farms, the amount of electricity that we're using in our households and homes and businesses is increasing every year by about 8%. So we need to get a lot of electricity to operate those systems. And of course, we want to have green electricity if possible. And I want to also mention that if you listen to thinkers in the AI space and people who know what's going on, they say the limitation for artificial intelligence is not the amount of chips that they can manufacture. The limitation is the energy to operate the AI systems. So this is a way to supply a tremendous amount of energy and operate those networks. So let's put this into summarize it. So if we look at how much the Canadian government spends to support the 3 Northern Territories, that's about $5.7 billion a year. Our total defense budget is about $26.5 billion a year. That's a very small amount compared to, say, the United States. And our total budget deficit was about $40.1 billion in 2023. So total federal expenditures about $496.9 billion. So if we could capture any one of those industries, those trillion-dollar industries, that would be a market that's bigger than the entire federal government budget. And if we can do this in the north, that would make these territories largely independent of Ottawa, and they would be able to spend the resources that they get from their tax money the way that they see fit. So, in summary, everything's in billions of US dollars except for the Canadian government stuff. So aquaculture, $277 billion industry and growing. Compute, 2.74 trillion. That's just for cryptocurrency. And AI will be a multi-trillion-dollar market in a few years. Potable water, well, just the bottled water industry is $342 billion. But of course, we could package other beverages. We could do bulk water sales. And if we're able to supply water to disaster areas, like, say the earthquake in Haiti or something like that, or if we are able to improve human health around the world, there's no price that you can put on those things. And in terms of energy, so we're looking currently at about more than $3.6 trillion a year. But if we can mitigate climate change, then that also would be priceless. So again, putting this in perspective, $5.7 billion. And we like to joke, the Canadian dollar is pennies on the dollar compared to the US dollar. But anyway, if we can increase our revenues, that goes a long way to helping increase the fortunes of my fellow Canadians up here. And of course, since I'm talking to a global market, this can be applied in the United States, this can be applied in Russia, this can be applied in Norway, and any country that really has access to the Svalbard Treaty or the Antarctic treaties can probably do this. I'm looking for partners from the Indigenous communities, and there are, I forget how many Indigenous communities, not very many, I think fewer than 100 all across the territories. So if they want to operate clean and renewable sources, then this is certainly an option. I'm looking for all levels of government to assist with this. So from the communities to the territories to the federal government. And one of the big things I'm looking for is cut through the red tape and change ridiculous laws. So there's a law that was initiated by the helium lobby that basically outlawed the use of hydrogen as a lifting gas. This was even before the Hindenburg disaster, but it doesn't make any sense if you think about it in the Arctic. So what's the worst case scenario if a remote controlled airship crashes and burns in the Arctic? Assuming it's not going to hit one of those communities, you're going to have this flaming hydrogen gas ball over basically tundra or over the ocean, and it's basically going to do no damage. And we don't generally have forest fires in tundra or muskeg. And then I'm looking for business people of all types to assist with this. This is obviously a multi-trillion-dollar operation, far more than I can handle on my own, that's for sure. So what do you see in this image? What I see is opportunity, and opportunity to help billions of people around the world. So that's my contact information, and I will stop sharing now. I noticed you were taking notes. Thank you.
Yes, that's a fabulous presentation. And I read things in the book and I've been to talk to you, but yeah, there's I have some little details here and there. Basically, that is really, really good.
Thank you.
And so having said that, and getting into the minor details, Billy Lee talked about, he had a way, he started with he wasn't speaking as an engineer, he was a popularizer of engineering. And he said, we're stuck on the thought of steam being in a boiler, but it's any temperature difference. And then he went from there. Then propane or butane can be a working fluid. And it's for a number of the audience, maybe starting with that, with a bullet point or something would be a little bit stronger.
And that's kind of what I was trying to get.
Fine by itself. I was just saying that would make it a little bit better. To just for catching particularly the non-technical politician, lawyer, accountant type.
Yeah.
And
I have his book here someplace. I don't see it right now on my shelf, so I must
yeah,
have misplaced it.
so
But
that's
yeah,
just that's a minor point there. And then
the way he says it is quite interesting. It's literally because as human beings, we think of energy, and anything that's hot has energy, and anything
yeah,
that's cold sucks energy out of us. But we don't think of it in terms of the difference, the
hmm
potential. And that's where that one slide came in. And I'm thankful to my friend Chris Gorham. He said, "This is what you got to do. This is the way you have to represent it.
hmm
Describe the energy as being a difference of potential."
yeah,
And that
delta
works.
T, difference in
Exactly.
temperature.
Well, delta T or chemical potential or
Mhm.
electrical potential or whatever, water level height, all of those are difference in potentials, right? So,
Yeah. Although in this case, we're just talking about a different temperature difference. And then another minor thing on the round of page 16, there was one very busy chart, which might break into a separate chart just so people could see it. If you're that information is important, yeah, put it there because people get cranky when they can't read and have the uh, little things there.
yeah, well, from everything oh yeah, okay, this is the hydrogen chart that you're talking about. Yeah, I didn't. The intention isn't to um, isn't to have people read it, and this is actually, I get failing marks in terms of this presentation for having too busy slides, but I just want to get so much information in there.
Mm-hmm.
But yeah, I mean, in the time that the slide was up, people wouldn't even have a chance to read all of those different things. The point was that the hydrogen economy and the ammonia economy are both pretty large, and a lot can be done with them.
Yeah, yeah. Of course, that is if they're not going to read it, you really need to put it there because it's crowding other stuff.
Yeah, fair enough.
Or as somebody else once said in speaking, sometimes you have to kill your children because you
Yes.
have all these ideas that you want to put out and tell people. But if it's sometimes less is more, it's clearer and done.
It's the same thing in writing. You have to like edit half of it away.
Yeah, a good chunk. And then, of course, my one of my pet ideas is there's and I forget the name of a Nobel laureate chemist who wrote the book. The let's see, he had the methanol economy, and then from that I said, well, how about the methane economy, which is another one. It's not as liquid as ammonia, but it burns quite well for both diesel and auto cycle
Mhm.
engines, and it's used widely also, or much more than ammonia. And so that's, and it's complication. Here's another possibility of,
Absolutely. Yeah, we could make methanol by capturing carbon dioxide from the atmosphere. And I talk
mm-hmm,
about a method of doing that in the book as well.
yeah, and
And
similarly
also,
methane. You just
yeah. And of course, in the Arctic, where there are natural methane seeps
mm-hmm,
because there's a whole bunch of methyl hydrates. So that's basically methyl captured in ice crystals. Um, and when the ice melts, the methane gets released. And this is a potential catastrophe in terms of global warming because methane has a much higher greenhouse gas potential than carbon dioxide does. So the best thing
mm-hmm,
to do in that situation would be to capture this fugitive methane
mm-hmm,
and burn it and produce energy from it. So
yeah. Of course, that would be a, you want to find another Canadian engineer to propose that. And that's another alternate energy source,
I
which
propose it
is
in the
also
book too.
vast. Anyway, going on, the next one was, and my own private thing, it's following the ocean currents. Spain is a closer market, and the Sea of Plastic is already in trouble. It's called the Sea of Plastic. It's an area of greenhouses in Spain, and they're already in trouble because they have been they've been sucking water up out of their aquifer. So they would definitely use the water product, and they would they're closer. So you're going to lose less. It's less time getting it there. It's a lot of market pluses.
Right.
Whereas further north, then like England and Ireland and northern France, they get a lot more moisture, so they don't
Sure.
more rain, so they don't need it. But Spain is a Mediterranean climate.
Yeah, I didn't mention
Much,
it in the presentation, but if you have a 1 terawatt plant,
mm-hmm.
then the operating at minus 40 degrees or something like that, the minimum amount of water that you would desalinate would be on the order of one of those 5 million ton icebergs
Mm-hmm.
every 2 weeks.
Yeah.
That's a 1 gigawatt plant, and what I'm proposing is we should build thousands of these 1 gigawatt plants,
Mm-hmm.
and of course that would give you enough water that you could start looking at using it for farming in the desert and that sort of thing.
Yeah. And yeah, Spain being the first one, Morocco the second,
Right.
Algeria, southern France,
Right.
much of Sicily, South Italy.
I should also point out when I was showing the Arctic Ocean freeze and thaw cycle, if you assume that the average ice thickness is about 1 meter or 1.1 meters thick, then that 10 million square kilometers equates to 10,000 cubic kilometers of fresh water that's naturally produced every year. That's just going back into the ocean when it melts. Now, I'm not suggesting that it's a great idea to go up there and harvest that unless you're replacing it somehow, because of course the Arctic sea ice has a lot of benefits for the ecology. And so my suggestion in the book is we could harvest that and then just allow more salt water onto the surface, or pump some salt water above the ice to replenish to make up for the amount that we're taking away. And I should also note that around Antarctica every year, the amount is significantly more than what's produced
Mm-hmm.
in the Arctic. So
Yeah, because it has a vast cold reservoir of ice that's at as much as 2 miles above sea level.
yeah, I'm just
So,
talking about the stuff that freezes and thaws every year, not even
yeah,
including the glaciers that calve off.
yeah. So I got those. Then the next little thing I was getting there might be used to yeah, maybe I think I might have mentioned, or I think the give bottled water its own page. I think you talked about it, but it would be a page for doing that. So I'm
Yeah,
getting at it. I'm going back to my job before I retired. The editorial thing is like, hey, now this is one place where add a page, add a little more text.
I don't hear that very often.
Yeah. Okay. And then on page 20, I really like the little greenhouse on the polar ice cap, because I grew up about 25 miles from Lorangle Wilder's little house on the prairie.
Right.
So that's like, hey, that's back in the
That was
history. I
my
remember that.
inspiration for the name of that slide. Yes.
And then as far as getting, it's more expensive, no matter how you deal with it, getting materials in and out of polar waters. But one of the proposals before they did the Trans-Alaska pipeline was submarines,
Right.
and that might be your way to go to get your fish out, especially since you're making more ice there. Of course, that does limit.
I mentioned submarines in the book, and the reason I didn't include it in here is because it's a whole different can of worms. And then,
Mhm.
then you probably, if you're operating submarines, you probably have DND looking at, issues, Department of National Defense. And also you need to have some sort of navigation system set up, because,
Mhm.
how are these submarines going to self-navigate, or are you going to have them crewed? And if they're crewed, then that brings up a whole bunch of other stuff. If you could just essentially send tanks with artificial intelligence controlling where they go, submarine is a pressure vessel to begin with. So you
Hmm.
just send that basically tank of fuel or whatever you're taking to, say, New York City, and then just offload the liquid, and then you go back up north and get some more. That would be ideal. And I think of like the James Bond movie, The Spy Who Loved Me, as being an example of how that could be done. If you're able to navigate the submarine right into the polar energy platform, and connect up to your
Hmm.
fill tubes or whatever, and then just go off on your merry way, that would be ideal. The advantage of using airships is not only does it become a transportation network for goods, but you can also use it if you get them certified for human use. You can use them for transporting people around as well.
Yeah, because I have my worries about that because airships were a great romantic thing, reading about it and so on, but just about all the stories except for the lucky ship, the Graf Zeppelin, it ended in an explosion.
Yeah,
Nobilier, the R-101,
yeah, no, I'm very
French
familiar with those stories, and all I can say
Akron,
about that is
Shenandoah.
we've learned a lot in the last 100 years. And let me just throw out another thought, because we don't necessarily need to have the hydrogen be on the outer surface. You could have like a barrier. Like a lot of the theories say that it was like a spark that caused the Hindenburg to explode because it was landing in like stormy weather, and so there was electricity in the air.
Yeah,
And
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 the wet ropes could carry a current, so
right,
a lightning flash would go right across the surface down the rope, and so then you have large charges moving
yeah,
through, and anywhere you have a little bit of a leak, even though it's not enough to mess up your buoyancy, it's quite flammable.
yeah.
And then when you start melting things, then everything goes to hell
Do
shortly.
do you know what they painted the Hindenburg with?
Yeah, it was. I forget the exact term, but it was like they doped it with very flammable material, just like they had on small aircraft.
Well, I'll tell you exactly what it was. As far as I understand it, they had like an undercoating that was like an iron oxide base, and then over top of it they painted aluminum.
Oh,
So they basically created a thermite skin. So
oh my
not
gosh,
not a very good idea. I think we can come up with better solutions than that.
gosh! I just heard about the kind of the gluey material that was also flammable, but not thermite. Oh my God! I think, yeah,
Anyways,
and that's
uh,
actually going where you were saying when you said, and it's for the most part uh, non it would be robotic aircraft. So if it burns, it's just the cost of the equipment. So well that is a plus right there. So you've got and that would be something else to emphasize at the front.
yeah, and my thinking along those lines is okay. So if you don't want to have hydrogen airships going down to New York City, that's fine. Let's do it so that like there's nothing to really catch fire in most of the Arctic. So we can have
Mhm.
a hydrogen acceptable area all the way from, say, I don't know, the Arctic of Canada, Greenland, Iceland, and
Mhm.
maybe northern Norway and the
Yeah.
Scotland. you know,
And let's see. What's our port in Hudson Bay? Uh,
Churchill. Yeah,
yeah, Churchill, and then you have railroad connections going down from there, I believe.
yeah, exactly. So if we could get the stuff to Churchill, then we can ship it by rail, and that operates year round, assuming that the railroad's in condition to operate.
Mhm.
And of course, they have issues with shifting, melting permafrost as well. So
Mhm.
and
Okay,
occasional flooding.
let's see. Then going on now, the now it's reading my writing. Oh, the cryptocurrency might mention yeah, they might be a little eccentric, but we see them as nice people with money. They 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 need their processing power and they're willing to pay for it.
Well, one thing that I
and
read
along
was,
along with the servers, and that was a good thing that making that point. So I was like, yeah, this is another one, bing, 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 a lot of good stuff in there. And then I think you just came up with a new material the other day that wasn't in the presentation about might have one page for recovering some of the energy from the server as power. So that would definitely be a good chart there.
yeah,
Then of course that thought occurred to me, gee, that same getting the server power as the server heat as an energy source, ocean thermal energy conversion, there is uh, about 2-degree water anywhere in the ocean if it's deep enough. So
right.
it's like, and this would be a nice thing. It could be kind of a smaller thing. So this is not for you, but for presentation for somebody that's talking about ocean thermal energy from the tropic waters. And
Yeah. Well, apparently they've got a plant that's operating now in Indonesia, so that's kind of interesting, at least
mm,
according to Grok.
yeah, I think there's been little plants that have gone for a while. Hawaii had one. I think India had one, and so on. They didn't. The efficiency level is pretty low. But
It's very
if you
low.
have
Yeah,
this other heat source, and again, that's a thing where it brings up nutrient-rich water,
that's right.
which that's not it. Well, actually, it is kind of an issue in the Arctic because it's the nutrient-rich water is saltier, and so the fresh water tends to be at the top, and so that's part of what makes the Arctic more of a blue water desert part of the year. I think in the summer it
Well,
kind of stirs up a little bit more because if you
I
get
know
open
that
water,
because
you get wave action and so on.
yeah, because the water is so cold, it's able to hold gases more efficiently. So you can have higher concentrations of carbon dioxide and higher concentrations of oxygen for life. So that
Yeah,
those are both benefits.
yeah,
Um,
but yeah, you
if
want your nitrates and trace amounts of iron, which is the issue of one of the complaint about ocean farming and it was hey, it was Native Americans that helped finance and run the boats that fertilized the water for that experiment. And a
mhm,
minor thing, the Svalbard Treaty and another treaty,
Antarctic Treaty, yeah.
that since we're marking things that if you're going to mention them, you just say there are treaties, and that might be something in a chart. And on the other hand, the summary got kind of long. If you could squeeze those down, that would be an editorial thing. But it's like boom, boom, boom. Had wonderful pictures. It, I think you managed to get them all things that were, government pictures and
Yeah, hopefully
things that wouldn't
the
be you wouldn't have
websites.
somebody calling to. They don't send you cease and desist anymore. They just send you the bill. Well, it might be being in Canada. It might help if they're American companies this year
I
anyway.
think like I don't know what the rules are, but as I understand it, you're allowed to use like images as long as you give the source and give the credit for pictures and that sort of thing. It's like isn't it called fair use policy or fair something along those lines?
There's yeah, that would do some. As long as you're not selling something.
Well,
And
I mean, I do mention the book, but it's not. I mean, it's not.
mhm. But as
I don't
many
know.
many things as you can,
We'll see.
Mark.
If we post this and I get a cease and desist order, then we'll comply, of course,
Yeah,
or we'll
usually
just
that's
blur
the
out the
most
image or
that'll
something.
happen.
Yeah,
And
it's not
especially if
like
you
I've been
say
making a
came
lot
from
of money.
government report such and such. I saw some very tiny writing, which I was some of the ones that you were giving the list. In fact, yeah, another way is you could just have a list, kind of like a throwaway list at the end.
Right.
If you
Yeah.
want my
So we could
references for
include
the art, here's this page.
when we when we post this video, I could put in all of the source images and stuff from in the comments or something like that.
Mm-hmm.
That
Yeah,
sounds reasonable.
yeah. But going getting repetitive. There were fabulous images all the way along. So that was good. And now you have 8 days for your other report.
I have to do some work for my clients, get a couple of invoices in, and then get the application in for the X Prize as well. Yeah, so it's going to be a tight, busy week.
Okay, all right. Good luck on that.
Thank you.
And I'm gonna, like I said, I'll see if I can put this in the YouTube, and maybe well, actually this will be a good test on things if anybody sends us a note or no. What I'll do is I'll post it on YouTube and I'll send you the other things. Actually, you can look at my YouTubes. I've got about three of them under Save the World Before Breakfast. And if it doesn't immediately pop up, just put my name and that should find it.
Okay.
And then this other one, I'll have it unlisted, but I'll send you the it's just the only way the reason can't people get to it is they can't look for it. But if you have the number, well, the ID of it. So I'll hopefully send that to you in the next couple of days.
Yeah, sounds
And
good.
you can see if hopefully this will work, because I don't want to have to be sending checks of $35 each time when it's like, hey, take a look at your Zoom meeting and see if you got anything to complain about.
Yeah,
Oh, by the way, it'll cost you $35. Oops.
so I think I gave you a link to my Dropbox page, and I
Yeah.
think that you can post stuff in there if I'm not mistaken. So, because I got a public folder that you can put stuff in.
Yeah. Well, I had that problem. The parting with Dropbox was not friendly. I had my credit card company. I said it didn't work and it got me trouble. I don't want to pay anything to them.
Right.
So yeah. So I don't want to talk to those people. They
Fair enough.
probably
Fair
don't want to
enough.
talk to me. Some big guy named Rico
Yeah.
who around my front door.
Well, one of the things that I'm looking at getting done is setting up a FTP server on my company website, and we can just post stuff there and keep it up as long as we need and transfer files that way. There's
Yeah.
no cost or anything associated with that, and that should be up and running in the next couple of days or next few weeks, anyways.
Oh, okay. Yeah. When you get it, send me the contact information and I can use that. So that's another one. All right, we got two options right there, and I think maybe hey, it's 9:16 for you, but maybe we could call it victory, especially since people are saying, you really should do 10-minute presentations.
No,
I
I
told
know.
them we were the Joe Rogan
Yeah, we're
school
competing with Joe
of
Rogan
succinctness.
for timeshare.
Yeah.
Yeah.
Yeah, Rogan is one who goes an hour or 2 hours at a time.
Oh, 3 hours, man. 3.5 hours I've seen him
Mm-hmm.
do. So yeah, I like deep dives, but I rarely have time to listen to them, unfortunately. So
Yeah, so a little one is people are more likely to go for it. But meanwhile, actually, the final thing on this is, you want to put your presentation, this one or the one you did before that you recorded to that at that conference, and you put it up. That's another way it makes you famous. Hey, there was this presentation, and here
well,
you can see it. And by the way, here's right behind my shoulder is is Infinite Resources, the book, and so that
Yeah,
gives another contact and, potential customers, potential people that want to build something like that. They can see your face, and then they can go to the book. So it's, more possibilities.
absolutely.
They'll never buy into things that they don't hear about.
Yeah, well, who knows if enough people see this and they decide to buy the books, then maybe I can start financing some of these projects.
Somebody says you won't make money by the books, but the book is a publicity
Well,
thing.
it's interesting. I one of the people who was at the conference has connections somehow or another to Andreessen Horowitz, so you never know. That's
Who's Andreessen Horowitz?
oh, they're a big venture capital company and based out of the San Francisco area.
Oh, okay. So yeah, one of the venture capital companies.
Yeah.
Excellent.
And
And
another thing that I've learned is there's a lot of government grants, and not only that, but here in Canada, but Germany, like I mentioned, has got a lot of money. They've just declared that the hydrogen industry is a strategic industry, so that gives it some priority, I think.
mhm, yeah, because yeah, that's a whole another thing where, as we mentioned in another one of these things, and there's been some articles about hydrogen deposits that have been found, which apparently were never noticed. The gas just
Yeah,
got away.
because it didn't follow the theory of like hydrocarbons are found in certain areas based on ancient
Mhm.
depositions and stuff like that. Where they're finding the hydrogen is, I think, mostly around like volcanic activity.
Yes, it's an igneous source versus, this is where Thomas Gold got in trouble. He was the one who said maybe petroleum could be igneous, and the petroleum geologists were furious. And they said, okay, here's this one site that he got to drill in. I think it might have been in Sweden, somewhere in Scandinavia, I believe. And it still, I think, came out uh, mostly metamorphic, uh, organic material that had been, left by probably diatoms or other oceanic creatures. But there's always been people proposing that there might be vast hydrogen deposits, especially like the mid-ocean ridges, are about 35,000 miles long, all told, going all the way into
Yeah.
the Pacific. And if these are igneous, then that other one goes through. That's a whole nother set of
Roger, you're
proposals.
missing the big picture here. Why have something that you have to drill to the bottom of the ocean for when you can just have something sitting on the polar ice cap going through the ice? I mean, it's so simple in comparison.
But the equipment, it's like as with solar and wind, the energy is immense, but it requires an investment in equipment to make it work. And like the French guy who was trying to
Well,
build them, he could never
yeah,
get it profitable.
yeah.
So we got better technology now, and using the cold is a whole new thing with it. Like, hey, it's got a bigger delta T than ocean thermal energy, but it's still, you have to have you tend to have a pretty large bit of equipment to get started. Once you start building them, if it's successful at all, then they would develop, they would evolve better technologies, cheaper, and it's just like the petroleum and gas industry has these huge platforms. Like, hey, we build them all the time. You go to the
Yeah.
Houston conference every year. They're talking about the next huge thing they're going to build, and doing maintenance on something that's been there for 20 years.
Yeah. I
And
didn't
billions of dollars go through those things.
I didn't draw attention to it, but when I was showing that thermodynamic cycle with all the heat exchangers and stuff, there was a picture of the Hibernia oil platform off the
Okay, I was
coast
wondering
of
which one it was. I said, that's a petroleum or gas platform, obviously.
Yeah, but essentially for the OTEC system that I'm talking about, it would be something very similar in terms of footprint. Of course, it would have heat exchangers and tubes for moving water around and stuff below the
Mhm.
water. And above the water, there'd be heat exchangers and stuff like that too. But I think the actual cost would be less than an oil drilling platform. So
Potentially, although you got the other expense, you might have to have a big icebreaker on call if ever needed. If some big keel of ice
so
came your way
yeah, my
and
my vision of this thing
moves
is it would have
around.
its own nuclear reactors on it, so providing some of that heat, and then it would be designed so it could be essentially a self-propelled icebreaker.
All right.
I'm
Okay.
serious. I'm serious.
Yeah. Well, that's another. Oh gosh. Yeah, that's another little presentation of a few pages that you
Well,
have in your back pocket
when
ready to
I get
go.
it, when I get the money to develop this thing, then we'll put all those ideas into motion. But
Mm. Okay. Well, anyway, I better let you go. And yeah, these other little side comments, they get to be their own presentations as well.
yeah, trust me, I could talk for this stuff. Well, I wrote a bloody book on it, so I could talk for hours.
Okay. Thanks a lot, and I'll post this hopefully the next couple days at the YouTube
All
and
right,
send you
thanks,
the
Roger.
contact.
Sounds
All
great.
right, and thank you for your presentation.
Thank you. Have a good one.
Okay, you too.